Hello there, folks. It's me, Bhoomika, again. As you already know, we are through with our in depth discussion over some of the questions of the JEE main paper, which was conducted on the 25th of February in the second shift. Today, we are going to resume our discussion over the remaining questions of the same paper. Alright, so without any further delay, let's get started. Now, let's move ahead and discuss this question from probability. It is saying there is a group of 400 people, out of which 160 are smokers and non-vegetarian. So let's say smokers and non-vegetarians are constituting the first event E1. 100 are smokers and vegetarian. So smokers and vegetarian are constituting the second event, let's call it E2. And remaining are 140 in number. So remaining means what? Non-smokers and vegetarians are 140 in number. So we have three events which you can clearly make out are mutually exclusive and mutually exhaustive, because when you add them up, you are getting 400. Yes, and if something belongs in E1, it doesn't belong in E2 or E3. If something belongs in E2, it doesn't belong in E1 and E3. If something belongs in E3, it doesn't belong in E1 and E2. Basically, their intersection is phi. Next, it says their chances of getting a particular chest disorder are 35%, 20% and 10% respectively. Let's say A is the event of person having the disease of having a chest disorder basically. So when I'm saying that their chances of getting a particular chest disorder are 35%, 20% and 10% respectively, that simply means that probability of a diseased person being from the first event are 35%. That is 35 by 100. Do you agree? Probability that a person has the chest disorder and is a smoker and non-vegetarian is 35%. Similarly, probability that a person has the chest disorder and is a smoker and vegetarian, that means it belongs to E2. This probability is 20%. That is 20 by 100. And probability that a person has the disease of going through a chest disorder and is belonging to E3 event, that means he is a non-smoker and vegetarian. This probability is 10%, that is 10 by 100. This is given to us. Now, a person is chosen from this group randomly and is found to be suffering from the chest disorder. Okay, so event A is occurring. The person who is chosen is suffering from this disease of having a chest disorder. What is the probability that the selected person is a smoker and non-vegetarian? Smoker and non-vegetarian means E1 event. So what is the probability of the occurrence of E1 event when you know A has already occurred? Isn't it? That's what's happening. A is occurring. The person chosen has the disease. So A is already happening. Under the happening of event A, what are the chances of E1 occurring? What are the chances of that chosen person being a smoker and a non-vegetarian? This question is typically based upon Bayes' theorem. So I want to compute what? I want to compute the probability of E1 by A, the conditional probability here. But based upon Bayes' theorem, what is the formula? This is probability of A by E1 into probability of E1 upon probability of A by E1 into probability of E1 plus probability of A by E2 into probability of E2 plus probability of A by E3 into probability of E3. Remember? Basic formula, Bayes' theorem. Just plug in the values. Probability of A by E1, that is 35%. So this is 35 by 100 into probability of E1. Remember, 160 out of 400 are members in E1. So probability will be 160 by 400. Yes, in here also 35 by 100 into 160 by 400 plus probability of A by E2, 20%, 20 by 100 into probability of E2. So out of 400, 100 are belonging in E2. So 100 by 400 is probability of E2. What about E3? Well, probability of A by E3 is 10%, that is 10 by 100. And probability of E3 will be 140 by 400. So 100 into 400 is the denominator, both from above and below it will be cancelled out. You will be left with 35 into 160, that is 5600 upon 9000, which on solving comes out to be 28 by 45. So this question was typically based upon Bayes' theorem. If you remembered its formula, it was a smooth sail to reach to the answer of this question, which is 28 by 45, sitting in option D, thereby implying that the probability that a selected person is suffering from chest disorder and is a smoker and non-vegetarian, what are the chances? 28 by 45. Cool? Belonging to the topic of determinants is this very question. It is giving us 3 linear equations in 3 unknowns, and you are being asked to comment upon the nature of the solution of this system. Mind it, guys, questions belonging to this category are very frequent to be asked in your JEE main paper. So let's quickly revise the concept whose knowledge you should have in order to crack this question. What is that concept? Well, whenever you are given a system of linear equations, what you have to first of all compute is 4 quantities: del, del 1, del 2 and del 3. What is del? Del is nothing but the determinant of the coefficient matrix of this system. When in that determinant, which is in del, when you replace the first column with this right hand side column of 998, what you end up getting is del 1. When in del, you replace the second column with this right hand side column 998, what you end up getting is del 2. And when in del, you replace the third column with this right hand side column 998, what you end up getting is del 3. Once you have computed del, del 1, del 2 and del 3, you have to remember that if del comes out to be a non-zero quantity, this means the system has unique solution. If del comes out to be 0 and along with that, at least 1 out of del 1 or del 2 or del 3 is non-zero, then this system has no solution. And if del is 0 and along with that, del 1, del 2, del 3, each of these 3 quantities are also 0, then the system will have infinitely many solutions. These are the conditions 1, 2, 3, which you should be well versed with in order to answer such questions correctly and quickly. So in here, what I'm going to do is, first of all, I'm going to catch hold of del, which is my determinant of the coefficient matrix of this system. Okay, so del will be what? Determinant of 2, 3, 1. So all the coefficients of x make the first column. Then all the coefficients of y will make the second column. So 3, 2, minus 1. And the coefficients of z, that's the third variable, will give me the third column. So 2, 2, 4. Alright, let's calculate this. Okay, so I'm going to expand it using the first row. What does this give me? 2 into 8 plus 2 minus 3. Then I have 12 minus 2 plus 2. And lastly, I have minus 3 minus 2. So this boils down to 10 into 2, that is 20. Minus 3 into 10, that is minus 30. Minus 5 into 2, that is minus 10. So what is this? 20 minus 30 gives me minus 10. Minus 10 minus 10 is minus 20. Wait a second. My del is coming out to be a non-zero quantity. I just shared with you that if del is non-zero, you can straight away conclude that your system is going to have unique solution. Alright, and this is where I'm done. My B is the correct option. I am not going to run behind what explicitly is that unique solution. I don't need that. Just check out the options. You don't need that. So why to waste extra time in this question? You are done here. It was that simple a question, that quick a question. B happens to be the correct answer here. There was no need to even talk about del 1, del 2, del 3 because del came out to be non-zero. Bingo, unique solution, and you are done. Got it? Let's now move ahead and discuss this question, which is based upon functions. You are given f of x and you are being asked to fetch its minimum value. Now, before I start attacking this question, there is just one concept that I want to revise with all of you. See, do you remember that the graph of a to the power x, where a is positive and x belongs to R looks like this. This is the graph of the exponential function. It is always strictly above the x-axis, and the point where it intersects the y-axis is 0, 1. Remember? And exponential function is defined only when its base a is a positive real quantity. How is this going to be useful in this question? You will just find out. Look at f of x. Look at f of x. It is the sum of two terms. Let's call this term 1 and let's call this term 2. I want to comment upon the nature of term 1 and term 2 independently, individually. So focus on term 1. It is a raised to the power a raised to the power x. I know as a matter of fact that no matter what real number x is, a to the power x is strictly positive. Yes, because I'm already given in the question that a is positive. So the base is positive, I'm sure of that. And x is varying over the entire set of reals. No matter what x real is, a to the power x is strictly positive, and a to the power any positive number. Can you see this? A raised to the power any positive number is again strictly positive. Corresponding to the positive real axis, the graph is taking up positive values, right? So this is again positive. That means my first term is certainly positive for every x real. Similarly, let's talk about term 2, which is a to the power 1 minus a to the power x. Again, a to the power x is positive. Yes, so I am getting a to the power x is positive, minus a to the power x will be negative, 1 minus a to the power x will be less than 1. Okay, that means this complete power quantity is taking up real values strictly less than 1, and a raised to the power any real number I know is positive. Yes, I know the power is taking real values less than 1, but I know as a matter of fact that a raised to any real number as power is positive. So term 2 is also coming out to be positive for every x real. Why am I so interested in assigning positive or non-negative signs to my both the terms involved here? Because the concept of minimum value or maximum value, whenever you want to compute the largest or the smallest value of a particular function, you incorporate the concept of AM-GM inequality, which is valid when the terms are non-negative. So in here I have even better case. I have both the terms as positive. So I am going to keep my term 1 and term 2 as, let's say, x1 and x2, and apply my AM-GM inequality in here. What am I going to get? This is my term 1, this is my term 2, that is x1 and x2. The AM-GM inequality says that AM is always greater than or equal to GM, and it is only applicable when the terms are non-negative. In here I have positive terms. I can successfully go ahead and apply it. So my arithmetic mean of x1 and x2 will be greater than or equal to the geometric mean of x1 and x2. Arithmetic mean means what? Their sum divided by 2. Geometric mean means what? Their product raised to the power 1 by 2. So compute the arithmetic mean. It will be sum of both the terms divided by 2 greater than or equal to positive square root of product of both the terms. Can you see here? A raised to the power 1 by x has been written as a upon a raised to the power a to the power x. Same thing. Why? Because from here I can certainly cancel it out. Why am I so confident that I can cancel it out? Because I know they are strictly positive terms. Right? I've cancelled it out. So my right hand side is only root a. Yes. So this gives me a to the power a to the power x plus a to the power 1 minus a to the power x is greater than or equal to 2 root a for every x real. This is nothing but f of x. You are getting f of x is greater than or equal to 2 root a for every x. That means the values that the function f is taking are at least 2 root a. So the minimum value that f is taking is 2 root a, which is sitting in option D. Alright, so we have used the AM-GM inequality here, but don't be blind, guys. First of all, the two terms on which you were interested to apply the AM-GM inequality, please ensure that they are non-negative terms. Okay, in here we first of all ensured that they are non-negative. In fact, they are positive, and then we proceeded ahead to plug in the AM-GM inequality in here, and that in one line only gave us the final answer to be 2 root a sitting in option D. Alright. And now the next question that we have to simply kill is this one from functions. Let's check it out. It is giving you an expression for f of x, and based upon just this definition of f, it is asking us to compute the value of this finite series. Let me rewrite this series for you, okay? So you have f of 1 by 20 plus f of 2 by 20 plus f of 3 by 20 plus and so on till f of 39 by 20. So before that you have f of 37 by 20 plus f of 38 by 20 plus f of 39 by 20. In order to tackle this question, all you need is superbly active observation. So bring in your vulture eye in picture and closely observe. In here you have the input as 1 by 20 and last term that you have is involving the input as 39 by 20. Their sum is what? 40 by 20, which is 2. In fact, from this observation, what can I say? That if I treat 1 by 20 as x, then 39 by 20 will be 2 minus x because their sum is 2. Similarly, 2 by 20, 38 by 20. Their sum is again 40 by 20, which is 2. So if I treat 2 by 20 as x, then 38 by 20 will again be 2 minus x. Similarly, 3 by 20 plus 37 by 20. Answer is 2. So if you treat 3 by 20 as x, 37 by 20 will be 2 minus x, and so on. From here, I can obviously catch hold of the hint that I am interested in the expression f of x plus f of 2 minus x, isn't it? Because that is how I'm getting the combinations being prepared here. So let's catch hold of f of x plus f of 2 minus x. The value of f of x plus f of 2 minus x. Alright. Now f of x is already known to me. It is 5 to the power x upon 5 to the power x plus 5. We only need to calculate f of 2 minus x. So how to do that? Well, in place of x, just plug in 2 minus x. You get f of 2 minus x as 5 to the power 2 minus x upon 5 to the power 2 minus x plus 5. Simplify this. This gives you 5 square upon 5 to the power x upon 5 square upon 5 to the power x plus 5, which in the next step comes out to be 5 square upon 5 square plus 5 to the power x plus 1. So this is 5 square as it is. From the denominator, I can take out 5 common. I'll be left with 5 plus 5 to the power x. 1, 5 cancels out. You are left with 5 upon 5 to the power x plus 5. Okay? So I have calculated f of 2 minus x. Now, this expression hence boils down to what? F of x, which is 5 to the power x upon 5 to the power x plus 5, plus f of 2 minus x, which is 5 upon 5 to the power x plus 5. This eventually gives you 5 plus 5 to the power x in the numerator and 5 plus 5 to the power x in the denominator, which is 1. So what are you getting? You are getting something extremely amazing, extremely fantastic. You are getting that f of x plus f of 2 minus x is actually 1 for every real x. Okay. Now, the sum that you wanted to calculate was of which series? F of 1 by 20 plus f of 2 by 20 plus f of 3 by 20 plus and so on plus f of 19 by 20 plus f of 20 by 20 plus f of 21 by 20 plus and so on plus f of 37 by 20 plus f of 38 by 20 plus f of last 39 by 20. Yes. Now, if you plug in x equals to 1 by 20 over here, what do you get? That f of 1 by 20 plus f of 2 minus 1 by 20, which is 39 by 20, is equal to 1. Similarly, when you plug in x as 2 by 20, you will get f of 2 by 20 plus f of 2 minus 2 by 20, which is 38 by 20, is equal to 1. And so on, f of 19 by 20, if you plug in x as 19 by 20, then 2 minus x will be 2 minus 19 by 20, which is 21 by 20. This is also equal to 1. What is this? What is this observation implying? It's very simple. First term plus the last term is 1. Second term plus second last term is 1. Third term plus third last term is 1, and so on. Basically, the sum of terms which are equidistant from the beginning as well as from the end is equal to 1. Such a mind-blowing observation is happening here, isn't it? Now, how many terms do you have in this series? 1 by 20, 2 by 20, and so on till 39 by 20. That means 1 to 39, 39 terms. 39 is an odd number. Divide by 2, what do you get? 19.5. That means you will have 19 pairs of 2 terms each, and there will be one middle term left out alone. What will be the middle term? 39 plus 1 by 2, that is 40 by 2, that is 20. 20th term will be the middle term, that is F20 by 20. This will be the middle term. Leaving this, you will have pairs of 2 terms. How many pairs? 19 pairs, each one of them giving you 1. Yes, so 1 plus 1 plus 1, 19 times gives you 19. Yes, plus this middle term, which is f of 20 by 20, that is f of 1. This is the final sum of this jumbo series. Yes, what is f of 1? Well, f of x you know. Just plug in x equals 1. What will you get as f of 1? It will be 5 upon 5 plus 5, which is 5 by 10, that is 1 by 2. So 19 plus 1 by 2, which is 39 by 2, is the sum of your given series, which is sitting as option C. Understood? Next up is this question from quadratic equations. Mind it, guys, this question belongs to a very common type, very common category, and there is a fixed approach, fixed methodology to crack it. Let's see. So here I have this quadratic equation with me, and alpha and beta are given to be its 2 roots. Also, there is a terminology which is being mentioned here, that alpha to the power n minus beta to the power n will be treated as an for every natural number n. Then, using all these pieces of information, you have to compute the final value of the expression a10 minus 2a8 upon 3a9. The very first thing I want you to do is expand this. Okay, using this rule. So, a10 will be what? Alpha to the power 10 minus beta to the power 10. Okay. Minus twice of a8 will be what? Alpha to the power 8 minus beta to the power 8. Alright. What about 3a9? It will be thrice of alpha to the power 9 minus beta to the power 9. Cool. This is giving us a hint that I am first of all interested in alpha to the power 10 as well as beta to the power 10. How to get them? Basic approach. See, if alpha is a root of this quadratic equation, that means in place of x, when you plug in alpha, the quadratic equation will be satisfied. So what will you get? Alpha square minus 6 alpha minus 2 is 0. From here I can say alpha square is 6 alpha plus 2. What do I want? Alpha to the power 10. So I will be multiplying both sides by alpha to the power 8. That will give me alpha to the power 10 here. Here I'm going to get 6 alpha to the power 9 plus 2 alpha to the power 8. Bingo! I have obtained alpha to the power 10. Are you getting what I'm trying to do? Similarly, I want beta to the power 10. So I'm going to use the fact that beta is also a root of this quadratic equation. So in place of x, when I'm going to plug in beta, the equation will be satisfied again. What that will give me? Beta square minus 6 beta minus 2 is 0, which gives me beta square to be 6 beta plus 2. Again, I want beta to the power 10. So I'm going to multiply both sides of this equation by beta to the power 8. That is going to give me beta to the power 10 on the left hand side. Right hand side will be 6 times beta to the power 9 plus 2 times beta to the power 8. I have alpha to the power 10. I have beta to the power 10. Plug it in this expression. Okay, let's do that very quickly. So alpha to the power 10 is 6 alpha to the power 9 plus 2 alpha to the power 8. This is alpha to the power 10. Minus beta to the power 10 is this much. So minus 6 beta to the power 9 minus 2 beta to the power 8. All right. What is next? Minus twice of alpha to the power 8 minus beta to the power 8. Write it as it is. Minus twice of alpha to the power 8 plus twice of beta to the power 8. This will become whole upon thrice of alpha to the power 9 minus beta to the power 9. Look at the numerator. Can you see? This gets cancelled out. Minus plus, minus plus. What you are left with? You are left with 6 times alpha to the power 9 minus beta to the power 9 in the numerator, and denominator is 3 times alpha to the power 9 minus beta to the power 9. This gets cancelled out. You are left with 2 to be your final answer. You got the approach? Your final answer is option C, that is 2. So the drill is very, very fixed and old school. If you are not aware of it, you can right now acquaint yourself with that drill which is used in these type of questions to crack them. You use the fact that alpha is a root of the equation and beta is a root of this equation. That gives you the expression for alpha square and beta square. Depending upon the demand of this expression, you multiply the remaining powers of alpha and beta to both sides to get the explicit values of those powers of alpha and beta, and that you plug it in this required expression. The terms get cancelled out, your expression gets simplified, and you reach to your answer within no time. Got it? Coming from the family of matrices and determinants is this interesting question. It is giving you that A is a 3 cross 3 matrix whose determinant is 4. The ith row of A is denoted by Ri. The question says if B is another matrix which is obtained by performing the row operation of row 2 goes to 2 times row 2 plus 5 times row 3 on 2A, then find the determinant of B. So first of all, understand the procedure which we will be following here. So we have A, from here we will obtain 2A, in which we will apply the operation row 2 goes to 2 times row 2 plus 5 times row 3 to obtain B, and from there we are going to talk about determinant of B. Alright, so A is a 3 cross 3 matrix. It looks like this. Fine. So 2A will look like what? 2 is going to get multiplied to each of these 9 entries sitting in this matrix. That's how you obtain scalar multiple of a matrix. So it will be 2 times A11, 2 times A12, 2 times A13, 2 times A21, 2 times A22, 2 times A23, 2 times A31, 2 times A32, 2 times A33. Alright, so this is 2A, which is of the same order as that of A. Now there is an operation which is being applied on 2A, that row 2 goes to 2 times row 2 plus 5 times row 3, and after this operation the matrix that you obtain will be the matrix B. Okay, so I am applying my operation on row 2, so first row and third row of the 2A matrix will not get disturbed, will not get affected. So first row remains the same, 2A11, 2A12, 2A13. Third row remains the same, 2A31, 2A32, 2A33. Okay, so what has to happen to the second row? It has to be converted to what? 2 times row 2 plus 5 times row 3. So 2A21 will transform to what? 2 times 2A21 plus 5 times 2A31. This gives you 4 times A21 plus 10 times A31. Similarly, 2A22 will transform to 2 times 2A22 plus 5 times 2A32. This will give you 4 times A22 plus 10 times A32. It's very simple, just basic mechanical steps. Next, 2 times A23 will transform to 2 times of 2 times A23 plus 5 times of 2A33, giving you 4 times A23 plus 10 times A33. This is B. Now, realize one thing. In here I have 10 times A31, in here I have 2 times A31. If I multiply this quantity with 5, what I'm going to get? 10 times A31 at both places, subtraction will give me 0. Similarly, there is 10 times A32 here and 2 times A32 here. If I multiply this by 5, at both the places I will have 10 times A32, subtraction will give me 0. Similarly, if I multiply this by 5, here I have 10 times A33, here I will have 10 times A33, again subtraction will give me 0. So what is this trying to give you a hint about? Are you able to understand? Yes or no? If I apply the operation that row 2 goes to row 2 minus 5 times row 3, you know as a matter of fact that even after applying this operation, the determinant's value will not get affected. All right. So what I'm going to get in the next step is first row remains the same. Third row remains the same. And second row becomes what? Just 4a21, 4a22 and 4a23. Both these determinants are equal to each other. Yes, we've learned about properties of determinants. That means even this is equal to determinant of B. All right. Fine then. Now catch hold of another beautiful observation. You can see 2 is sitting in each entry in the first row. 4 is sitting in each entry in the second row. And 2 is sitting again in each entry in the third row. In a determinant, I can extract out a scalar common from one complete row or one complete column. So I am going to extract out 2 common from the first row, 4 common from the second row, 2 common from the third row. When I do that, I am left with determinant of A11, A12, A13, A21, A22, A23, A31, A32, A33. This, guys, is nothing but determinant of A, isn't it? This is determinant of matrix A. Wow! We already are given in the question that determinant of A is 4. So this boils down to 2 into 4 into 2 into 4, which in the next step simply gives you 16 times 4, that is 64 to be your final answer. Okay, 64 is sitting here comfortably in option A, so A is correct. This question I would grade to be really simple. Yes, it was mechanical. Yes, calculations were involved, and yes, it was demanded from your end to be little accurate. But it was not at all challenging. Pretty straightforward steps. Option A, correct one.